Okay, so this one is the second one of 5. This is thermal decomposition of carbonates. You have copper carbonate, calcium carbonate and zinc carbonate. Alright, you need to know for this what happens in thermal decomposition. Alright, you need to know these reactions, you need to know these equations. So the apparatus that we are using for this is scales to measure it out, lime water to measure the products of our reaction. This should give you a massive clue as to what's going to happen. We have lime water in our test tubes. We have zinc carbonate in a boiling tube. We have calcium carbonate in a boiling tube on our clamp stand, ready to go. And we will also have copper carbonate in a test tube. So we get the copper carbonate. You notice that it is green. You might see an interesting colour change happen with copper carbonate, which is often a question. All right, I will go back to that when I do copper carbonate. So you have copper carbonate there in that test tube. Remember, it's green. Very important. Zinc carbonate and calcium carbonate are white. All right. So what we have is the Bunsen burner. Obviously it's on safety flame because I'm being very safe, but we will put it on to this one. And the quicker the thermal decomposition reaction happens, the less reactive the element, okay? The least it holds on to its carbonate. Okay, so what you would expect to see is calcium carbonate being slow, zinc carbonate being in the middle, and copper carbonate being nice and fast. And remember that you did these, or some of these at least, in the lesson. We are testing to see with lime water. So what are we testing? We are testing carbon dioxide production. You can see that it is heating. Some gas is being released from the delivery tube into the lime water. However, the lime water is not going cloudy. Okay? That means there is no carbon dioxide present. Thermal decomposition is not happening as yet. Alright? That's just something called thermal expansion. Alright, you can see lime water has not gone cloudy, it's stayed normal. Let's have a look at the others. So we turn our back to a safety flame. And we keep our lime water there. Take our goggles off. And let's put it that way. Now remember your control variables in this experiment. You would need to time how long each one of them you're doing it for, and you need to know how long it takes. All right? It's recommended you don't do it for more than 2 minutes. That's because it's dangerous. But I would say, I just need to get another test tube rack. Sorry, ladies and gentlemen. I would say that the longer you burn it, all right, the more time it has to react. So you need to control that. Each one you need to time. Right, so let's give zinc carbonate a go. We are moving down the reactivity series. You need to remember the trends that these show, okay? So there we have zinc carbonate and lime water. My goggles on. Safety first. Okay. So we are definitely getting, this is the zinc carbonate, remember? And we are definitely getting a reaction taking place. It's turning yellow, and there is a gas coming through. Now can you see that lime water, remember this, is turning milky and cloudy, alright? Those are the words you need to use, milky, cloudy, white. Don't use any of the other words, please. Alright, so you have thermal decomposition occurring. CO2 is being given off carbon dioxide, and the test for it is lime water. And as you can see, that thermal decomposition is a lot faster for zinc carbonate than it was with calcium carbonate, and that is because of the reactivity of the metals. Okay? Right, so we shouldn't really do that more than 2 minutes, so I'll stop now, because I've shown you a decent amount there. But it did take a little while. It took about, I would say probably about 30 minutes, not 30 minutes, sorry, about a minute for it to go cloudy. So let's have a look with our final one. Let's have a look with calcium carbonate, with copper carbonate. Copper carbonate is our main one. It's the one that we mostly do in schools. Now that's a really favourite question, and I've seen it in quite a few past papers. Why would copper carbonate be the most useful one to do in school? Alright, I've seen that quite a few times, and we did talk about it and do some questions on it. Okay, so there you see it, it's green, remember? It's actually a real vivid green. It's a lovely colour, and we're going to put a bung in there. It's not a lot, I'm afraid. Another thing to control is your weight of each of the compounds that you put into your test tube, remember. Get our lime water, which is colourless. Remember, when you talk about changes, you must begin with the colour and then end with the end colour. Do not just give me the end result, that misses you marks. And let's see if this is
Each first lady came today, and she is, yeah.
So here we are, heating, trying to thermally decompose. And can you see there's a lot of gas being produced there, and a black solid being produced. There's a colour change, green to black. And there's a lot of gas being produced, and the lime water has gone cloudy within 30 seconds. So copper, being the least reactive of all our metals, between calcium, zinc and copper, has least been able to hold on to its compound, okay? And it's being thermally decomposed at a lower temperature. Alright, so there you have it. That's your thermal decomposition of carbonates experiment. Remember, the keys to this one are the colour changes, testing the lime water, because carbon dioxide is a product. So your colour changes are with zinc, it goes to a yellowy powder. There's actually a yellowy gas produced as well. And with copper carbonate, you get a black colour change from green. And your lime water with calcium carbonate has not changed at all. With zinc, it's gone sort of cloudy. And then with copper carbonate, it's gone very cloudy. That's very important. And remember to say cloudy or milky, don't lose your marks with anything else. And that's all you need to know for this experiment. Thank you.